Chapter 6, Section 3, Dividing Polynomials. In this section, we'll learn to divide polynomials using long division and divide polynomials using synthetic division. First thing, let's go slide over on this corner over here to make sure we understand when we talk. When we divide a number, it's the divisor. So if I'm trying to divide 24 by 6, 6 is the divisor. Okay? And whatever the top part of the divisor is the quotient. So 24 is the dividend, 6 is the divisor, and 4 is the quotient. Okay? So you can use polynomial division to help find all the zeros of a polynomial function. Division of a polynomial is similar to division of a numerical number. Okay? So we have the dividend of 56, the divisor of 8, and 8 will go into 56 7 times, and there is no remainder. Okay, it has a remainder of 0. So the divisor, 8, and the quotient, 7, are both factors of the dividend, 56. If there is a division remains, a remainder remains, there is neither a divisor or the quotient is a factor. So look at the next example. Okay, the dividend is 42. Okay, the divisor is 5. The quotient is 8. So how many times will 5 go into 42? So it'll go into 8. 5 times 8 is 40. So you got to subtract 2. So there's a remainder of 2. So we know without a doubt neither 5 or 8 is a factor of 42. The exact same thing is with polynomials division. They are only factors if there is no remainder. So the example they have below is 2x squared. They want to divide it by x. Well, x will go into that 2x times. 2x times x is 2x squared. There is no remainder. So x and 2x are factors of 2x squared. To divide polynomials other than monomials, you need to follow the same procedures when you divide by whole numbers. So let's look at the example in the book. We'll just kind of go through the book, see if this makes sense. Using long division, we're going to divide this polynomial x squared plus 3x minus 12, and we're going to do our best to divide it by x minus 3. Well, x minus 3, the first part will go to x. We can multiply x. X times x minus 3 is x squared minus 3x. So now we'll subtract those, and you get 6x, because remember, if you're going to subtract them, you're going to add x squared minus x squared, 3x plus 3x, so it's going to be 6x minus 12. Okay, so the next step, we drop down the negative 12, we add 6 to see what we can get. So 6 times x is 6x, so we'll put that right there. 6 times negative 3 is negative 18 right there. So we subtract them and we get a remainder of 6. So the quotient 6 plus, or x plus 6 with a remainder of 6. So, or simply, the quotient is x plus 6 are 6. So it's not a perfect factor. So let's work this one together. Divide, alright, divide x squared minus 3x plus 1. We're going to divide that by x minus 4. Okay, well, the first one will be x. So x times x is x squared. X times negative 4 is negative 4x. Like we said before, we got to change the signs to subtract them. So the x squareds go away. 4x plus 3x, or 4x minus 3x, is going to be a positive x plus 1. How many times can we do that? So we will multiply that by 1. So we'll make that plus 1. 1 times x is x, and 1 times negative 4 is negative 4. Again, we've got to change the symbols to subtract them. Negative x and positive 4. So x minus x is 0, and 1 plus 4 is 5. So we have a remainder of 5. So we're looking for x plus 1, comma, r 5 is our solution. We see that is B. Okay? Next example. Let's check some factors. Alright, so it says determine whether x plus 4 is a factor of each polynomial. Okay, going through the steps, and I'll rewrite these and do them myself on the side. Okay, for A, the polynomial is x squared plus 6x plus 8. So we've got the divisor of x plus 4. We know that'll go in x. That'll give us a value of x squared plus 4x. We've got to change the signs to subtract them. So that's going to leave us a 2x. We've got to drop down the 8, so it's 2x plus 8. Okay, so to get x to be 2x, we've got to multiply it by 2, a positive 2, so we're going to say plus 2. 2 times x. 2 times x is 2x. And 2 times 4 is 8. Again, change the signs down here so we can subtract them. So 2x minus 2x is 0, and 8 minus 8 is 0. So it looks like these are factors. So the factors of that polynomial x squared plus 6x plus 8 is x plus 4, which was our divisor, and x plus 2, which is our quotient. Okay, so on A it worked. On B, we have x cubed plus 3x squared minus 6x minus 7. We got a divisor again of x plus 4. So let's look. Change colors here for us. So to get x cubed, we have to times x by x squared. So x squared times x is x cubed, and x squared times 4 is 4x squared. We got to subtract those, so change the signs. X cubed minus x cubed is 0. 3x cubed minus 4x cubed is negative 1x cubed. Okay, so we got to drop down. The next part would be minus 1 or 6x. Okay, to get x to be a negative x squared, the next divisor, the next part of the quotient would be minus x. So minus x. Let's scoot this up a little bit for us. Negative x times positive x is negative x squared. Negative x times 4 is negative 4x. To subtract them, we got to change the symbols. Okay, the x squareds go away. Negative 6x plus 4x is negative 2x. We got to drop the last part down. So minus 7. Okay, so we got x plus 4. So we have got to get x to be a negative 2x, so we're going to multiply by negative 2. So negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. Change the sign so we can subtract them. Negative 2x plus 2x goes to 0. Negative 7 plus 8 is 1. So we have a remainder of 1. So our answer on this one would be x squared minus 2 minus x, comma, remainder of 1. And that is not a factor. Okay. Okay, next example. Determine whether x minus 8 is a factor of 2x squared minus 19x plus 24. Remember, this has got to divide out perfectly to be a factor. So let's divide it. 2x squared minus 19x plus 24 is our polynomial. Our divisor is x minus 8. Alright, to get x minus 8, or get x to look just like 2x squared, we have to multiply it by 2x. So 2x times x is 2x squared. 2x times negative 8 is negative 16x. Okay, we're going to subtract, so we're going to change the symbols, change the signs. 2x squared minus 2x squareds go away. Negative 19x plus 16x becomes negative 3x. We got to drop down the positive 24 plus 24. Okay, so now to get x to look just like the first part, we got to multiply it by what? We got to multiply it by negative 3. So let's see what happens here. So we're going to multiply it by negative 3. So negative 3 times x is negative 3x. Negative 3 times 8 is positive 24. Change our symbols to subtract, so that becomes plus, that becomes negative. So it factors out perfectly. So the factors are x minus 8 and 2x minus 3. So the answer is yes, x minus 8 is a factor. Okay, another example for us. Determine whether x plus 2 is a factor of x cubed minus 4x squared plus 3x plus 2. So let's write the polynomial down. X cubed minus 4x squared plus 3x plus 2. X plus 2. Okay, to get x cubed we have to times it by x squared. X squared times x is 3x. X squared times positive 2 is plus 2x squared. So now let's subtract those, so that means we got to change our signs. So x cubed minus x cubed is 0. Negative 4x squared minus 2x squared is negative 6x squared. Now drop the next part down, so plus 3x. So we've got to make it match negative 6x cubed or negative 6x squared, so we're going to have to multiply by a negative 6. So negative 6 times x, I'm sorry, negative 6x. Negative 6x times x is negative 6x squared, so they match up. Negative 6x times a positive 2 is a negative 12x. Again, we got to change the signs to subtract, so we're going to subtract them. So negative 6x squared plus 6x squared is 0. 3x plus 12x is 15x. Okay. And after the 15x, golly, after the 15x plus 2, to get that we have to multiply by a positive 15. So 15 times x is 15x plus 2 times 15 is 30. Let's change our signs to subtract. That's going to be 0 and a negative 28. So we have a remainder, don't we? So the answer would be no. It's not a perfect factor. So that's the first part. Going on to the next part. So part B of dividing polynomials, we're going to use synthetic division. To divide linear factor, you can use a little bit more of a simplified process known as synthetic division. In synthetic division, you omit all the variables and the exponents. And by reversing the sign of the divisor, you can add throughout the process instead of subtracting. Okay, so how does that work? Let's just look. Okay, we're just going to walk through these examples together, and then we'll do some samples at the end. Okay, using synthetic division, it takes a little bit getting used to. So you'd write, you're going to divide 3x cubed minus 4x squared plus 2x minus 1, and you're going to divide it by x plus 1. Okay, so we're going to reverse the sign of the constant term in the divisor and rewrite the coefficients of the polynomials in standard form. Okay, so what we're saying is we're going to write it up like we normally would. Okay, just like you normally would in standard form. And then we're just going to flip the the constant term, make it negative 1. And then we're just going to drop down the coefficient in front of each term. Okay. Bring down the first coefficient, which is a 3. Multiply the first coefficient by your number, so negative 1 times 3 becomes a negative 3. Add those terms, be negative 7. Okay, and then do the same thing again. Negative 1 times negative 7 is positive 7. Add those two terms. 2 plus 7 is 9. 9 times negative 1 is what? Negative 9. So that'd be negative 10. Okay, so right now that was the last step, so is not 0, so we have a remainder of negative 10. Okay, and again, just walk through the steps over here in the video too. Step 1 was drop down the first coefficient. The second step is multiply the first coefficient by the negative divisor and write that number or that result underneath the next coefficient, add them, multiply by the negative divisor, so on and so forth until you get to the remainder. So you can rewrite the quotient as 3x squared. So this one would be 3x squared minus 7x plus 9 with the remainder of negative 10. Okay, that's a little bit confusing at first, I understand. Don't worry, we'll work through some samples of this. Okay, use synthetic division to divide this quotient, x cubed plus 4x squared plus x minus 6. Divide that by x plus 1. Okay, so let's rewrite this. Let's make this a negative 1 for our reverse divisor. Okay, the coefficient in front of that one is 1. The coefficient in front of the x squared is 4. The coefficient in front of the x is 1. And the constant term is negative 6. So we drop down the first term. Negative 1 times 1 is negative 1. Add those together, it's positive 3. Positive 3 times negative 1 is negative 3. 1 plus negative 3 is negative 2. Negative 1 times negative 2 is a positive 2, so that's negative 4. So let's rewrite it. So it'd be basically x squared plus 3x minus 2 with the remainder of negative 4. So our answer would be A. Okay, once you get the hang of this, the synthetic one will be a little bit easier. Okay, if a polynomial p x of the degree n, where n is greater than 1, is divided by x minus a, where a is a constant, and then the remainder is p parentheses a. You can reuse the remainder theorem to find the values of p sub x. So let's look at what that means by that. Let's evaluate this polynomial by synthetic division. Okay, using synthetic division to find p of negative 4 for p sub x. Alright, where x is x to the 4th minus 5x squared plus 4x plus 12. Okay, so let's look at this before we move on. Let's we got p of negative 4, so we write negative 4. Our fourth power, our coefficient of the x to the 4th is 1. Our coefficient of x to the 3rd, there is no x to the 3rd in this top equation here. There is no cube, so our coefficient for that one is 0. Our coefficient for x squared is negative 5. Our coefficient for the linear, or x, is 4. And our constant term is 12. So we have it set up, so we drop down our first coefficient. Negative 4 times 1 is negative 4. 4 plus 0, negative 4 plus 0 is negative 4. Negative 4 times negative 4 is 16. Negative 5 plus 16 is 11. Negative 11, or negative 4 times 11 is negative 44. 44, negative 44 plus 4 is negative 40. Negative 40 times 4 is 160, so 172. So the remainder is 172. So p of negative 4 is 172, where p represents the negative coefficient of the divisor. Right, this example, use synthetic division to find p sub negative 1 for p sub x equals 2x to the 4th plus 6x third minus 5x squared minus 60. So let's set it up. You got your negative 1 already set up. Your coefficient of x to the 4th is 2. Your coefficient of x to the 3rd is 6. Your coefficient of x squared is negative 5. Your coefficient of x is 0. And your constant term is negative 60. So if you remember what we do, the first thing we do is we drop down the 2. 2 times negative 1 is negative 2. We add those together is 4. 4 times negative 1 is negative 4. Add those together. Okay, so negative 9, or negative 5 plus negative 4 is negative 9. Negative 1 times negative 9 is 9. So 0 plus 9 is 9. 9 times negative 1 is negative 9. So negative 60 minus 9 is negative 69. So the piece of negative 1 is negative 69. So the answer would be A. Okay. Now you have your homework. You got the worksheet 6.3, 1 through 21 odd.